Whoops. The last talk here is I've been volunteering so many people that they finally said, well, what are you going to talk about? So I figured I'd give you a bit of an update on Allstarlink, specifically for the version 3 of Allstar and how we've been integrating that into ColMon. So as you'll remember, I gave a talk about ColMon last year at NERDfest. And basically, ColMon is a rewrite of the Allstarlink Allmon server. And particularly what we were interested in is that when we have voting receivers, it's important to actually integrate that into the display, just showing what all of the node connections are. So that very busy graph on the right-hand side shows you basically that we have the Colorado ColMon, in that particular case, pulled up with the receiver on Thoroton receiving some signals. At the same time, somebody from Colorado Springs is doubling with them, and somebody from Salida is also doubling with them. So we can see the signal strength for all of the different ones. We can see all of the ones that are keyed up, which are showed by the right key on the right-hand side, and the ones that actually are locally repeating, it'll show up in the top left-hand corners, or right-hand corner, but to the left. So basically, ColMon was a complete rewrite of the original Allstarlink. And the thing that we added for a network as large as ours is that it is actually a hierarchical system. Basically, what runs on every individual Allstarlink node is the ColMon server that directly talks to the Asterisk instance. That ColMon server communicates with the Asterisk over TCP, so it can actually run on a different node. But typically, we would run an instance on the same server so that we can actually have it go out and look at the ColMon configuration file, which configures the ColMon settings, but also the Allstar settings, right? So it can go over there and read, for example, the rpt.conf, which configures the different repeaters. And by putting a comment in the rpt.conf file for each of your nodes, you can then have some text string that would normally be used in the Allstar database. But the advantage is that we have local configuration of that particular setting as opposed to something that you have to do in some database. It'll also look at the manager.conf file so that you know which ports to talk to and those kinds of things. It'll look at the voter file to see what the names of all of the voters are and so forth. The key thing, though, then, is that ColMon will basically feed stuff upstream, and the part that Chris, K0SWE, wrote is this API that takes all of the more text-based stuff and actually displays it in the web browser. And so the pretty graphics that you see on this particular page, that's all done in JavaScript with an appropriate WebSocket interface to the ColMon API to actually feed all of the data in and show you real-time updates as far as all of those things are concerned. So a typical hierarchy would look something like this. So here we have 3 different clubs, the Colorado Connection, the CRA, and the NCARC, and each of them have a ColMon instance that you can go and look at in the configuration of all of those. You can use that to link and unlink the repeaters, see the status, and so forth. But the big advantage of using ColMon is that we can actually feed this up into a hierarchy to the very top that we call Megamon. And the advantage of Megamon is that because it knows of every repeater that touches the RMHAM network, we can now, on an ad hoc basis, say, oh, for this event, what we need to do is to take this one Colorado connection repeater, we need to take one of the LARC repeaters and one of the NCERC repeaters and form an ad hoc linked system that is active only during that event. And so it gives us the ability to, for both emergencies and planned events, reconfigure the network and link different computers, repeaters together in essentially an ad hoc way. Now, of course, in order for this to work, what we actually need to do is to teach each of the individual All-Star instances about all of the other nodes that it can connect to. So in the configuration file for Asterix, you need to have a radio entry for each of the nodes that it can connect to as well as connect from. And so the way that we've implemented that is that Megamon that knows about all of the different nodes can be polled by a service. In this case, we just use DevDB, which is the program that we use to manage basically all of the devices on the RMM network. But it'll go to Megamon and say, can you tell me the IP address, the ports, and all of the node numbers that you know about so that we can build a database of all of the nodes and the IP addresses to connect to or connect from that we can now go and advise all of the other machines from. And so in DevDB, there's a feature where you can go in and say, go and tell all of these other nodes about the existence of these other nodes so that you then can set up the links. And then, of course, once you actually connect the nodes together, they don't talk through ColMon or through DevDB. These nodes directly connect to each other as long as they can find each other on the network, of course, and then actually set up those cross-linking. You can either daisy chain all of those nodes together, so you connect node 1 to node 2, node 2 to node 3, node 3 to node 4, and so forth. They'll pass audio that way. Or you can designate one of them as a hub, and everybody just connects to the hub and pass traffic that way, right? That's sort of the more common way of configuring that. This is all great, but there's one big problem with this kind of configuration, which is if a new node is added to the system, that node gets propagated up to Megamon, and Megamon knows about it. DevDB can immediately get that information and then distribute it all to all of the nodes. But in order for a node to be able to connect, you need to go and restart Asterix on each of the nodes, right? So you basically have to restart every Asterix node on the system in order for this to work because it needs to reread those configuration files. This is a chore. So that's where ASL3 comes in. So ASL3, which is basically version 3 of the Allstar, is a relatively new release. And basically what was had happened was that the original code that Jim Dixon wrote 30 years ago now, 40 years ago now, it worked great, but it was ugly as sin. And so there was a grant from ARDC to a group of folks that basically said, we need to take that technology, but we need to bring it up to date. Because the original All-Star, which we now call All-Star 1, was built against a very old Asterix implementation. This new module was built against Asterix 20, which is basically the latest, if not very close to the latest. And in particular, how it was built was that it was done through a set of modules that you basically link into the kernel for a modern Debian implementation. And so the really big change is that today with Allstar 3, if you want to upgrade the kernel or make any updates to the operating system because you're running a current version of Debian or Raspberry Pi, you can basically just say get upgrade, and it'll upgrade everything, and there are hooks in the modules that if the kernel changes, it'll rebuild the DADI modules and all of those kinds of things. So you can keep the code up to date with all of the latest security patches and things like that. And if there are new features added to Allstar, it'll basically download the new Allstar modules and everything just builds. And I've tested this numerous times. It basically, just is a flawless process for upgrading it. So that is a very, very significant upgrade in the newest technology. In addition to having these new modules, there's also something called the Unbound DNS Resolver. And the idea behind that is that instead of always looking up the nodes that you can't connect to or will accept connections from, we're using DNS to actually do those lookups. And so you've probably seen that in both the HamView IP implementation and the Allstar 3 implementations, that instead of having to maintain this long list of all of the possible servers, you can now also just use a DNS style request to get that kind of information. And I'll dig into that here in a little bit. But the main thing about ASL3 is that it's very stable. It plays nicely with older implementations. And so it is definitely recommended that you upgrade to ASL3. So the one big change with ASL3 is that the configurations files for the new version is not backwards compatible with the older ones. So they do provide a script called ASL menu that you can use to actually do that initial configuration. But basically you need to do a fresh install if you want to upgrade between an older ASL version and a newer one. There are some changes to the syntax, such as, for example, in the older configurations, what we used to have is something called an include if exist reference. So how we configure, for example, the Colorado connection is to have sort of standard stanzas for what does a voter looks like, or what does a hub look like. And Mark in 7CTM spent an awful lot of time getting the K2AD seal of approval on having the right beeps and boops and all of those kinds of things for the Colorado connection so that all of the repeaters sound the same. But by using those include clauses, we basically were able to just have a standard way that each of them will sound. There is still a feature called try include in the newer version of ASL3, but they really added a new feature called a template, which basically kind of does the same thing, except that the way you do it is you explicitly define what you want a standard repeater to look like or sound like, and then you can just reference that in each of your node references and then do whatever customization for that particular node you need to do. So it's a really convenient way of doing things. The other thing that changed was the extensions.conf file now has a very funky format. And the way that I have just resolved that was to just brute force it and just have explicit entries for all of the nodes that I need to allow on my local node. However, there is supposed to be a generic way that you can do it, but I don't think either Dave or I has figured that out yet. And then, of course, there's a whole bunch of new modules that were introduced, different channels and other capabilities. But the particular one that I'm interested in is this Resolve Unbound particular module. And so how that works is that instead of having a DNS server that talks to the rest of the system from through the kernel, which is basically controlled with etc resolve, which says go and talk to that particular DNS server to get whatever IP address to name translation you need for the kernel itself. Built into Asterisk, there is a separate DNS resolver. To get it, you have to add in the modules.conf the load res resolver unbound module. That actually isn't in the modules.conf commented out for some reason. You actually have to manually add it, but it's not that big a deal to just add that one line. And then in your resolve unbound.conf file that basically controls this module, you simply add a line that says name server equals, and then you give it an IP address. And then basically within the Asterisk framework, it will go and do DNS lookups to get the node information. So basically, the system works exactly the way that I showed in the previous slide, except now what happens is Megamon actually writes the zone file for this DNS resolver. And then we have just a regular bind instance that runs that reads that zone file and then serves it up to all of the Asterisk nodes that needs to query them. The nice thing about this, though, is that everything happens in real time. So when everything bubbles up to Megamon, if it sees that there's a node change, it'll basically rewrite the zone file, send a hop over to the bind server. The bind server will reload that zone, and then any node that wants to connect to another node or has an incoming connection to from another node will then basically query the bind server and say, hey, is this allowed, and what's all the information from that particular server. And basically how it works is just using DNS records just exactly like this. So the overall zone name is called nodes.allstarlink.org. Unfortunately, that is not configurable right now. It's one of my feature requests to Allstarlink is because we run a private network, we're going to run our own DNS network for the node configuration, but we have to basically trick Allstar into using our name server for this particular node, and that prevents us from linking out and using a different DNS server for something else. So it would be nice if we can actually have a subdomain or some other way of defining these are all private nodes, and these are the other ones are the external ones. So for now, we'll basically just use this, but you'll see that there's basically an address record. So 1801 INA is for node 1801. That's its IP address. What was added for VoIP phones was a type of record that's called a service record. So the particular record that has underscore IAX dot underscore UDP dot the node number is a service record. And basically what that has is two priorities and then a port number and a node number, right? This is a type of DNS record that was added for VoIP phones so that it could figure out the appropriate ports. And since we're just using the exact same technology, that particular address record or type of address record is what we then use to teach Asterisk that in order to connect to node 1801, the IP address it gets from the INA record, and it gets the port number from the service record. The last record there, the text record, is simply a way of letting human beings query the database and see what the result is. So it's just a special type of text record where we again use the node number, but we have information in there that is basically just a bunch of fields where the contents is completely arbitrary, but it's something that a human being can read. So for example, NN equals is the node number. RT is the time when this was last updated. The RB and PIP we don't have to worry about. The port is specified with the PT, and then the RH is who actually generated this particular record. So in this case, it was generated by ColMon or Megamon, really. But for the external version of this, it basically has the hierarchy of how all of the information actually bubbles up in the Allstarlink infrastructure. And so the long and short of all of this is that I've been very impressed with ASL3. It's been very solid. I've run it on a couple of nodes, some which are actual repeater nodes, some that are hubs, and it is rock solid. Even though it's a .0 version, I generally don't install .0 of anything. But 3.0 is very solid, and it plays well with all of the older versions. So no problems with running a mixed network with some All-Star 3 and some of the older All-Star stuff. This real-time updates with the bind records is really convenient. There's a way that you can run ColMon with DHCP. So you can actually set it up so that it will figure out its own IP address and then call the Megamon server to actually tell it that here's where I am. And so that allows us to basically configure an all-star node at home and then taking it to the mountaintop and let it just find an IP address through DHCP. And it automatically becomes part of the system. And because it reports its IP address and things like that up the stack, which then gets reported through DHCP, DNS through all of the other servers, that node, even though it's moved IP addresses, now becomes available to all of the other nodes in the system. So a very, very convenient way that requires little human interaction for configuration. Just a little bit of upcoming attractions in ColMon. The next thing that I've been working on is to actually integrate All-Fall into ColMon. That's basically the way that we can actually have a history of the key ups on all of the different repeaters. That's very convenient for debugging purposes. That's currently a completely standalone subsystem, but it actually does a lot of work that is duplicative of what ColMon does. So that's one of the things that we're going to integrate into that. And the thing that I need to twist Chris's arm on in working on is what I refer to as control operator presets. So for example, if you have a network that is configured for a certain class of operation under normal circumstances, but then you're going to run a net on Sunday and you want to connect in some additional nodes, that through that same web interface that we can use with ColMon, we can grant control operators access to that. Access, of course, is controlled by the web protocols and logins, but then have basically a set of presets that says, okay, I want to configure the network for the Sunday morning net, let's say, and then it'll do whatever linking and whatnot needs to happen. And then in the same way, unlink it and put it back into its standard configuration. Our biggest challenge in all of that has just been in keeping with the distributed configuration that we've done with ColMon other ways, that normally it's the owner of the repeater that controls the configuration and the information about it. That's still just some of the details that we're working out is, how would we actually do where do we store all of that configuration information and so that's still stuff that we're agonizing over. So I think that's all I had. I know I'm the last thing that stands between you and lunch, so I'll take a few questions if you have any, but otherwise, that's our presentation for today. Any questions? So just again, a reminder that RMHAM is a 501c3 public charity. We bring these kind of presentations to you based on the goodwill of people that contribute to RMHAM. So please bear that in mind whenever you make your charitable contributions. And I hope to see you at the Swap Fest tomorrow. One last thing is our next RMHAM University is on March the 8th. So it's a different week or different Saturday of the month, next month, and it will be an antenna workshop presented primarily by Doug K2AD, but it will be what he calls antenna tapas. So it'll be, a lot of different presentations about different kind of uses of antennas and, applications or different styles of antennas for different applications and all of the things that you can try, or if you have input on that, please let us know and we'll give you a slot as part of that presentation. So if you're, for example, into POTAs and you have this really fantastic antenna that you want to tell everybody about, you should have done it today at NERDfest, but since you didn't, please let us know and we'll make time for you during the antenna workshop on the second Saturday, March the 8th, I believe is what it is.
Hey, Willem, is the audio on?
Yes, it is.
It is. Yeah, and the reason I'm calling it antenna tapas, those are small plates. So yes, especially if you have a great POTA backyard antenna, we'll give you a short slot. You don't have to prepare 3 hours of presentation. It could be 10, 15 minutes, but share to get people on the air.
Thank you, and we'll see you tomorrow.
Let's put one last plug in for HamCon. Registration is open.
Oh, yes.
And I will give you the little flyer. We want to make John Maxwell happy.
Yes. What camera should I look at?
Let me do his little zoom, little whip zoom.
I'll do my Vanna White.
There you go, Vanna White. That would be a good picture.
Thank you all.